Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going to be going through the grade 12 mathematics paper 2 November 2020 exam. Alright, we are going to be focusing particularly on question 8. I've made an awesome summary video on all the theorems that you guys need to know when it comes to Euclidean geometry. The only theorem that is not included in that summary video that I will put a link to in the description box is the theorem that basically talks about the proportionality theorem. So that's the only theorem that I haven't included in my summary video. All right, but yeah, I've created a nice and awesome summary video for you guys to help you approach these Euclidean geometry questions or geometry rider questions. Okay, before we get started with the video tutorial, make sure that you just copy down the question, you draw the diagram, and you just try it out on your own. Right, once you've done that, play the video to just check to see that you understood all the concepts. Okay, so we're gonna get started by reading the question. Question 8.1 says that O is the center of a circle, right? KOM bisect chord LN and MNO is equal to 26 degrees. We are told that K and P are points on the circle with NKP equal to 32 degrees. And we are told that OP is drawn. Okay. The first question asks us to determine, given reasons, the size of O2 and the size of O1. Okay. Before we get started with just like determining the sizes of these two angles, let's just analyze what we are given in the question. Okay. We are first told that KOM bisects the chord LN. We are told that angle MNO is equal to 26 degrees. We are told that K and P are points on the circle, and we are told that NKP is equal to 32 degrees. Let's just see what all that means on the diagram, right? If we are told that a line bisects a chord, what does that mean? Because we are told that the line KOM bisects the chord LN, right? What does that word bisect mean? It means that NM is equal to your LM. So bisect means that it has basically cut through the line in LN equally. Okay, let's look through the next set of information that we are given. We are told that MNO is equal to 26 degrees. So that is simple. We just know that that angle there for our triangle MNO is equal to 26 degrees. We are told that point K as well as point P are points on the circle, meaning that they are points that are on the circumference of the circle. And lastly, we are told that your angle NKP is equal to 32 degrees, right? So that is your angle NKP, and we are told that it is equal to 32 degrees. So now let's look at the questions, right? Question 8.1.1 is asking us to determine, giving reasons, the size of our angle O2 as well as our O1. When working with geometry riders or Euclidean geometry questions, you need to always remember the acronym Dr. K-Town. And I know that someone out there might be thinking, "Sisifunda about Dr. Manch." And no, we're not learning about doctors, all right? So the D stands for diameter, the R stands for radius, the C stands for cyclic quadrilateral, the P stands for parallel lines, and the T stands for tangent. So if you can remember this acronym, then you can figure out the approach that you should use for a given question. Let's look at this question that we are given here in particular, right? In this question, we do not have a diameter, but we do have a radius, okay? where is our radii? Our OK is a radius, our OP is a radius, and our ON is also a radius. In this question, we do not have a cyclic quadrilateral. We do not have parallel lines, and we do not have tangents, right? So we need to remember theorems that talk about a radius or a chord and a circle, because we are given a chord and we are given a radius. The chord that we are given is the chord Ln, and obviously we are given radii, which is the OK, the OP, and the ON. So let's ask ourselves, what are the theorems that talk about either a radius or chord? The first theorem is the radius or chord theorem. Okay, and the second theorem is the theorem that talks about an angle in the center and angles that are on the circumference. Okay, if you don't know what I'm talking about, guys, please make sure that you go and watch the summary video that I've created for you guys. The link will be on the description box. So when we think about the theorem that talks about a center angle and an angle on the circumference, then we can see that, oh my gosh, this question becomes so simple, because then that theorem says that a center angle is equal to 2 times the angle that is on our circumference. We're already given our angle that's on our circumference, which is K1, and that is equal to 32. And we are looking for the center angle, which is like our O2, right? Then we can just simply use that theorem to get our K1. Therefore, and we mentioned that our O2 is our center angle, right? So O2 is our center angle, and we also mentioned that the K1 is the angle that is on our circumference, and we know that we can use the theorem that says the angle that is at the center is equal to 2 times the angle that is on our circumference. And then the explanation you can give there is angle at the center is equal to 2 times the angle at the circumference. And we are told that our K1 is equal to 32 degrees. Therefore, we can see that our angle O2 is equal to 64 degrees. So I'm just going to put that on our diagram. We are done. Next question. Determine, giving reasons, the size of our angle O1. So since we are told that KOM bisects our line LN, we know that the line that is drawn from the center of the circle to the midpoint of a chord is perpendicular to that chord according to the radius or the chord theorem. I'm going to repeat that, right? Because we are told that the line KOM bisects our line LN, we know that if you draw a line from the center to the midpoint of a chord, that line is going to be perpendicular to that chord according to the radius chord theorem. Remember, I mentioned that we need to always think of the acronym Dr. K-Town when we are answering our questions. We said that we do not have a diameter, okay, in this question. Okay, we can't say that the line LMN is a diameter. This is not a diameter because it's not a line that is going through the center. So we can't say it's a diameter, right? We did say that we do have like a radius or a radii in this question. And we confirmed that the radii is OK, OP, as well as ON. We said that we don't have a cyclic quad, and we said that we don't have parallel lines as well as tangents, right? Because we've got radii, right, that means that there are 2 theorems that we need to be aware of. The first one, which is the radius or the chord theorem, and the second one is the theorem that talks about a center of a circle and points that are on the circumference, right? We've already dealt with the first theorem, okay, which is that talks about the center of a circle and points that are on the circumference, and we're able to get our O2. The second theorem now that we are going to make use of is the theorem that talks about the radius and the chord, the radius chord theorem, right? That theorem tells us that our line OM is perpendicular to our line LMN. How does that help us to get to our O1? Do you guys agree that To get our O1, we first need to get our O3, and once we have our O3, we simply use what we know about angles that are on a straight line to get our O1, right? So if we can get our O3, then our problem is solved. So how do we get our O3, guys? Since I mentioned that our OM is perpendicular to LN according to the radius chord theorem, we know that our angle N2 is equal to 90 degrees. Do you guys agree? That angle is going to be equal to 90 degrees. And once we see that that angle is equal to 90 degrees, do you agree that we just use the sum of angles in a triangle to get our O3? And then from there, we use the sum of angles on a straight line to get our O1. So let's just get our O3. So we said that our OM is perpendicular to our LN according to the radius or the chord theorem, and because of that we mentioned our N2 is equal to 90 degrees. So our angle N2 is equal to 90 degrees, right? And once we've calculated our N2, then we can calculate our O3. And how can we get the value of O3? The sum of angles in a triangle equal to 180. So we're just going to say 180 minus 26 degrees plus 90 degrees to get our O3. And the reason that we put here is, and therefore we find that our O3 is equal to 64 degrees. Guys, just punch it into your calculator, right? And confirm that it is in fact 64 degrees. And we're just going to put that into our diagram and see how that is going to help us. So we found that our O3 is equal to 64 degrees. Then I said that once we have our O3, what can we see? What can we see about what's happening on our line KOM with our angles O1, O2, and O3? We see that they're actually angles that are on a straight line. And what do we know about angles that are on a straight line? Angles that are on a straight line are equal to 180. So to get our O1, we are just simply going to say 180 minus the 64 plus that 60. Okay, so 180 minus 64 plus 64, when you punch that into your calculator, you get 52 degrees. So I'm just going to add that to my diagram, and we found that our O1 is equal to 52 degrees. Okay, we are done. Next question. We need to prove, giving reasons, that our Kn bisects our OKP. So I'm just going to highlight my line Kn, right? That's the line Kn that we're working with. So that's the line Kn that we're working with. And we need to prove that it bisects OKP. So where's our OKP? The O, that's the K. So the key word here is bisects, right? And what do we know about bisects? If something bisects something, that means that you are left with two equal sides on either side of the line that is doing the bisecting, right? So the line that is doing the bisecting is our line KN, okay? And we are told that this line bisects, okay, our angle K. This line bisects this whole angle here. Okay, this whole angle here, right? Meaning that our angle K1 and our angle K2 are equal. So now we need to prove that these two angles are equal. So how are we going to prove that these two angles are equal? So we can prove that K1 is equal to K2, right? By just solving or trying to find our K2. So if we can find the actual value of our angle K2, and it is in fact 32 degrees, then we have proven that your Kn bisects OKP. Okay, so this is such a nice question. So let's do that. Let us try and find what our value of K2 is going to be. Okay, I'm just going to bring your attention to this triangle in particular. So guys, if we have a look at triangle KON, okay, so if we look at this triangle, what is it that we can see? Remember guys, we are still working with this whole Dr. Cape Town acronym, okay? And we said that we're working with a radii because we see that we've got radii, okay, in our diagram. We know that OK as well as ON are radii. And what do we know about radius of a circle? They equal, okay? So our OK is equal to our ON, okay? And once we can see that these two are equal, what does that tell us? Because our ON is equal to KN, it means that our triangle OKN is an isosceles triangle, meaning that the angles that are opposite the sides that are equal. Okay, so the angle K2 is going to be equal to the angle N because we are working with an isosceles triangle because we know that our OK is equal to our ON. Okay, so then we're done, guys. We've proven. If we know that, how can we apply this on paper? So I'm just going to redraw the triangle for you guys quickly so that you see what is happening. Okay, we said that our triangle OKN is an isosceles triangle. And guys, since we've already said that it's an isosceles triangle and I explained why it's an isosceles triangle, that angle there, our O1 plus our O2, is equal to what? O1, the angle O1 plus the angle O2 is equal to 52 plus 64 degrees, okay? And that is equal to 116 degrees. So I'm just going to put that there, okay? So that is 116 degrees, okay? So now all we need is angle K and angle N. So how do we calculate K and N, right? So all we need is angle K2 and our angle N there, all right? So I've just redrew that so that you see what's happening. Okay, since we already know that these angles are equal, what we can do is we can say that 180 degrees minus 116 degrees is equal to 64, right? And since we know that these angles are equal, if we take that 64 degrees and we divide it by 2, we'll get the angles for K1 as well as N. So our K1 angle is equal to 32 degrees, okay? And our N is equal to 32 degrees. And if you check, right? If you check, 32 plus 32 plus 116 will give you 180. Okay, so the trick here is just seeing that the triangle OKN is an isosceles triangle, right? And once you see that it's an isosceles triangle, what do you know about an isosceles triangle? We know that the angles that are opposite the sides that are equal are also equal. And then from there, we've already calculated the angle O. We've already calculated angles O1 and O2. Okay, so we add them together to get the total for the O that's on our triangle KON, and we found that it's 116 degrees. And from there, we took that 116 degrees and we minused it from 180 because of sum of angles in the triangle equal to 180. And then we divided that by 2 to get 32 degrees. Okay, so we took the 180 minus 116, we've got 64, and we divided that by 2 to get 32. And all of this is because we are working with sum of angles that are in a triangle. So we say that the ON is equal to KN, okay, because this is a equal radii. And because we are working with an isosceles triangle, the angle N is equal to the angle K1. And the reason for this is because we've got angles. So the opposite angles to the opposite sides that are equal are equal. So that is the reason that we use. Okay, and from there we have proven that our Kn bisects OKP because we've proven that K1 is equal to K2. Okay, so from here I'm just going to fill in the information. We found that our K2 is equal to 32 degrees and we are done. In question 8.2, we are given the following information. So in triangle ABC, F and G are points on sides AB and AC respectively. D is a point on GC such that D1, the angle D1 is equal to angle B. For question 8.2.1, if AF is a tangent to the circle passing through points F, G, and D, then prove, giving reasons, that FG is parallel to BC. Remember guys, when we are approaching our geometry writers, we need to always remember the acronym Dr. Cape Town, okay? We need to check to see if we've got a diameter, we need to check to see if we've got a radius, we need to check to see if we're working with a cyclic quadrilateral, we need to check to see if we've got parallel lines, and we also need to check to see if we've got a tangent. Okay, so let's look at the information that's given. We are told that F and G are points on sides AB, okay, AC respectively. D is a point on GC such that D1 is equal to B. So we're just gonna fill in that information. They're telling us that our B1 is equal, our D1 is equal to B. So I'm just gonna color that in. So that angle there is equal to this angle there. That's what is given. Now looking at the question. If AF is a tangent to the circle passing through points F, G, and D, then prove, giving reasons, that FG is parallel to BC. So basically here they're telling us this is a tangent. Our line AF is a tangent, right? So they're telling you if this is a tangent and this line AF is a tangent to a circle passing through the points F, G, and D, then prove, giving reasons, that the line FG is parallel to the line BC. Need to prove that these two lines are parallel. So that's what we're trying to do, right? The first thing we're going to do with this question is we're going to draw this circle. So we're going to draw a circle that touches points F, G, and D. So, okay, so the circle touches points F, G, and D. Okay, so that's the circle that we're working with. Okay, and we've got a tangent. So already guys, we can see that in this question, we are working with the tangent and we're going to be working with parallel lines. If we can prove that FG is parallel to BC. I'm just going to redraw this question so that you are able to follow properly. So I've redrawn what we are given here, okay? Because I've got the point F there, and I've got the point F there, and we've given the point F there. We've got our point G there, and that's my point G there. And we've got our point D there, and I also have my point D there, right? So I've basically redrawn the circle and taking into consideration what we are told, right? So we are told that AF is the tangent of the circle passing through, and that circle is passing through the point F, the point G, the point D. So that's how our circle is passing through the points. So I've basically done that here, okay? So the question is asking us to prove, giving reasons, that the line FG is parallel to the line BC. So how can we prove that these two lines are parallel? We know that, okay, if you're working with a tangent, you need to remember that there's certain theorems that you need to remember that deal with tangents. In this case, we've got a tangent and we also have a chord, right? And then remember that there's a theorem that tells us about a tangent and a chord. If you have the angle that is created by a tangent and a chord, okay, is equal to the angle that is in the alternate segment, okay? So according to the tan-chord theorem, angle F1 is going to be equal to the angle D. Okay, so that angle is going to be equal to that angle there according to the tan-chord theorem. Okay. And the angle that is formed between a tangent to a circle and a chord, so that angle there is equal to any angle in the alternate segment. And the angle that's in the alternate segment is the angle D. So now we've actually calculated or proven that our angle F1 is also equal to our angle D1. So I'm going to color that in. So angle F1 is also equal to our angle D. F1 is also equal to D1. And we also were given that our D1 is equal to B. So we're going to write that down. And this is given. Therefore, because we see that our F1 is equal to B, this tells us that our line BC is equal to our line FG because those two angles are corresponding angles. Okay, so you found that that angle there is equal to that angle there, and these two angles are corresponding angles. And we know that if you have corresponding angles, that means that the two lines are parallel. Okay, for we have proven that your FG is parallel to BC. So quickly, what we did with this question is that we have to prove that our line FG is parallel to our line BC. Okay, we are told that our line AF is a tangent, and we are told that there's a circle that touches the points F, G, D, and F, right? So you're going to put and draw that circle on those points. Once you draw that circle, you think, okay, we're working with Dr. And with Dr. Cape Town, if we have a tangent, we need to remember the theorems that tell us about the tangents, right? And then we know that for a tangent and a chord, there's a theorem that talks about a tangent and a chord. And that theorem says that an angle that is formed between a tangent to a circle and a chord drawn from that point of contact is equal to any angle in the alternate segment, right? So by using the tan-chord theorem, we're able to see that our angle F1 is equal to our angle D1. And once we got that, we were given that our angle D is equal to our angle B, right? And from there, it became super easy because we could see that now we had corresponding angles. And when you're working with corresponding angles, you know that you've got parallel lines. And then we have basically proven that FG is parallel to our BC. And the last question, we are asked if it is further given that AF over FB is equal to 2 over 5, AC is equal to 2x minus 6, and GC is equal to x plus 9. then calculate the value of x. So I'm just going to bring your attention to this. If you are basically given something that resembles a ratio or a fraction, then there needs to be a light bulb moment where you need to kind of remember that you need to be working or dealing with the proportionality theorem. Okay, so if you see something like your AF over FB, which is equal to something, then that needs to basically be a light bulb moment that you need to basically work with or apply proportionality theorem. Okay, so in question 8.2.1, we've already proven that FG is parallel to BC. Okay, so since we know that our FG is parallel to our FG is parallel to our BC, we see that we need to use the proportionality theorem, which states that if you draw a construction line, which is the FG, parallel to one side of the triangle, it intersects the other two sides, which is your A to C of the triangle, and divides the remaining two sides proportionally, right? So this is the construction line that is drawn. And this construction line divides the AG and the GC proportionally. All right. Furthermore, we are given the information that your AF over your FB is equal to 2 over 5. So we want to put in that information. We are told that AC is equal to 2x minus 6. We want to put in that information. And we're told that GC is equal to x plus 9. We want to put in that. Okay, AF is equal to 2. We are told that FB is equal to 5. We're going to put that down. We are told that AC is equal to 2x minus 6. We're going to put that down. So that's the A and that's the C. So AC is 2x minus 6. And then we are also told that GC is equal to x plus 9. So that's the G there, and that is the C there. And we are told that this length there is equal to x plus. So what does the proportionality theorem state? Okay. So the proportionality theorem says that AF over FB is equal to AG over GC. Okay. So your AF over your FB is equal to your AG over your GC. So that's the proportionality theorem, okay? And then we were told that your AF is equal to 2, and we were told that your FB was equal to 5. And what is our AG? What is our AG? Okay, so if you look at the diagram here, you'll see that the AG is equal to, so that's the AG that we're looking for. So that's our AG. And what is the AG equal to? AG is equal to AC minus GC. Okay. AG, so that's your AG, that small part there, the black part there, is equal to the red part, which is the AC, minus the green part, so that you'll be left with the black part, right? So we're going to write that down. We said that AC minus GC all over, and then GC remains as GC. Okay, so we need to basically calculate what the value of x is. So by using the proportionality theorem, we will be able to basically use the equations that we were given, substitute them into this formula to be able to solve for x. Okay, so let's just do that now. What was our AC? Our AC was equal to, okay, So I'm just going to write down the AC here, which is the black part. So the AC is equal to, this is my AC, is equal to 2x minus 6. So we're minusing that part. Then we're taking the 2x minus 6 and we're minusing the x plus 9 so that we can get the AG. Okay, and then we're just going to substitute that into our equation. And then what is our GC? Our GC is the green part, which is x plus 9. So we're just going to put that into our equation. And then here, guys, we are simply going to solve for x. Okay. It is very important for us to realize for question 8.2.2, for us to be able to calculate the value of x, it is very important for us to realize that we're working with the proportionality theorem. And you know what? You have to know what the proportionality theorem states, right? So to just do a recap, I said that the proportionality theorem states that if you draw a construction line, which is the FG, parallel to one side of a triangle, it intersects the other two sides of the triangle and it divides the remaining two sides proportionally, right? So this construction line divides your AG and your GC proportionally, right? Meaning that your AF over your FB is equal to your AG over your GC. And once you've got that equation down, it's going to be very simple because from there you substitute the values that were given to you, right? And we also saw that if you have to use your AG is equal to your AC minus your GC to get your AG. And then from there, you just simplify your equation and you just solve for x. Okay, and then that is it. In the next video, I'm going to be doing question 9 of the November 2020 paper 2 exam, and this question wants us to basically prove the tan-chord theorem. So if you actually want to find out how you prove the tan-chord theorem and you like how I explain things, then make sure that you are subscribed to the channel because I am going to be doing that on my next upload. And yeah, guys, I hope you guys enjoyed the video tutorial. Please make sure that you guys comment and tell me how you found the video, and also don't forget to give this video a huge thumbs up. And yeah, guys, I really appreciate the support, and I'll see you guys on my next upload. Goodbye.